Hello everyone, welcome back to my YouTube channel. In this video, I shall discuss on a question related to ideal gas law. So let's get started. A 15-liter steel tank contains a mixture of nitrogen gas and carbon dioxide gas at standard temperature and pressure. The partial pressure of nitrogen gas and carbon dioxide gas are 0.6 atm and 0.4 atm respectively. Predict the mass of carbon dioxide gas in the tank. Alright, so from the question, we were given the partial pressure of the gases. So basically, we have nitrogen gas and also carbon dioxide gas with partial pressure of 0.6 and 0.4 atm. So what we can do is we can find what is the total pressure. So the total pressure is equivalent to 0.6 plus 0.4. Therefore, your total pressure is equivalent to 1 atm. So this fits also with the STP, which is 1 atm as the pressure. So the next thing we can do is we need to find what is the total number of mole. So we are going to use the ideal gas law, PV equivalent to nRT. So your P is 1 atm, your V is 15 liter, N is the one that we want to calculate, R is the gas constant 0.0821 liter atmosphere divided by mole Kelvin, and your temperature is at STP, so it's going to be 273. So your N should be equivalent to 15 liter times 1 atm divided by 0.0821 liter atmosphere per mole Kelvin times 273 Kelvin. So like always, we need to remove all this unit that we can first. So you will end up having just mole for your unit. So your N is equivalent to 0.6692 mole. So this one is the total number of mole. Okay, so in the question you were asked to predict what is the mass of carbon dioxide gas in the tank. So before we can predict the mass, so what we can do is we need to find what is the number of mole for the carbon dioxide gas. So the partial pressure which is given in the question, the partial pressure for carbon dioxide is 0.4 atm is equivalent to number of mole divided by the total number of mole times the total pressure. So now the partial pressure is 0.4. The number of mole is the one that we want to calculate, and the total number of mole is equivalent to 0.6692 times 1 atm. So this one is going to be mole as well. So this one is atm. Okay, so now you have to rearrange this. So you're going to find the N, which is the number of mole, is going to be 0.4 atm times 0.6692 mole divided by 1 atm. So basically this one you can just slash this 2, you will end up having the number of mole should be equivalent to 0.2677 mole of carbon dioxide gas, CO2. Alright, so in the question you were asked to calculate the mass. So number of mole is equivalent to mass over RMM. Therefore, your mass is equivalent to mole times RMM. So basically your number of mole is 0.2677. So you just have to calculate the RMM for CO2. So basically it's going to be carbon is 12.011 and oxygen will be, because there's 2 oxygen, so 2 times 15.999. So basically what you're going to have is 44.009. So this one is mole and this one should be gram per mole. So definitely you can slash this out and you will get the mass is equivalent to 11.7810 gram of carbon dioxide. So this is the final answer for this question. Thank you very much for watching this video from the beginning till the end. So I'll see you again in the next video. Goodbye.